All right, so what should we look for? How's the data organized? Is it a text file? Is it a CSV file? Is it XML? So really basic things we might want to understand. How the structure of the data. We might start to want to know, like, okay, maybe there are records. What do they mean? So to guide in this really basic process, we kind of came up with a list of things to look for. So the first one is structure. So what is the shape of the data file or files? I'll elaborate on each of these in a moment. So the first one is structure. Second is granularity. So there might be records. What do they represent? Are they individuals? Are they populations? Think about what is the meaning of the record in terms of the subject we're trying to study. Related to that is scope. Does the data reflect the things that we are trying to study? We can kind of look at this in the context of a sampling frame. So does the data cover the population? Is it drawn from the population? Is it too large or is it too small? Temporality. This one's tricky and interesting. Time. How does time play in? So when was the data collected? When we look at timestamps in the data, do they mean when the data was entered into a database? Do they mean when the subject was asked a question? So understanding the role of time in our data. And then faithfulness, which is sort of a catch-all for a lot of the other problems that we see. Do we trust our data? Are there inconsistencies that we might need to address? Okay. So these are really basic ideas. Once we've walked through these, then we start to explore trends. And in fact, actually, we'll use tools of visualization to explore those. So as we get to visualization lectures, we'll look at pairs of variables and how we can kind of extract ideas of relationships between variables. And then as we get into modeling, we'll actually try to confirm or evaluate those ideas. All right, so structure. Well, you've been using pandas for a while, and we started with SQL, so we certainly have a bias towards data that's in the form of tables. Probably all started using spreadsheets. It is an easy way to think about data. It's organized in a table. Rows are my examples, and columns are the kind of fields or properties I'm trying to study. So we prefer our data to look like this. So these data structures are easier to manipulate. They're easier to analyze. There's a certain degree of regularity between the rows. So this is kind of how we want our data to look. A big part of data cleaning is getting it in this form. All right, so we talked about, and actually I'll go through these quickly. So we've talked about two. So we talked about tables and matrices. And I think in the first pandas lecture, we kind of compared the differences between them. The key one being that tables can have data of many different types in the columns, whereas a matrix is a data structure where all the elements are of the same type. And tables have a richer language of operations we can apply, whereas matrices are restricted to linear algebra. Many things you will do in data science will be going from messy data to tables, and then ultimately to matrices to do interesting analyses. All right, so let's look at some files. These are real files. How is this file formatted? So you get this file, like, great, I got some cool data. Tell me about it. Start simple. What's the most obvious thing you see in this file? Yeah. It's a CSV file. What is that? Is it not a CSV? It's not a CSV. It's a TSV. What is that? Don't worry, we'll get to CSVs. These are tab-separated values. Good. So we've identified some piece of structure. What else can we say about this file now that I have it open? Simple things. Columns. Column labels are at the top. That's nice. We don't have to go figure it out. We know roughly what the columns mean. Everyone knows what CVDOW means, right? I have no clue what that means, actually. No, I do. I'll figure it out later. So there are column labels. That's useful. Maybe not a complete picture of what's going on with this data. There appears to be rows. And rows seem to have new lines at the end of them. So I opened up in Sublime. Oh, I can use this to point. Aha. So in Sublime, it shows these line numbers here. So it shows that I have new lines for each of my records, the first record being the column labels. I get to see things like quotes. I see lots of interesting structure, and we'll come back to this data in particular and look at it. But that's one. So tab-separated values. Its related cousin. Basically the same thing, but comma-separated values. So knowing the delimiter in these files is pretty important. We've already used Pandas Read CSV. It can read TSV as well. So any of these delimited files we can load fairly easily. In a moment, I'll talk about why these could be a little bit problematic. But I want to put up a third data type that's pretty common these days. What is that? JSON. Great. What is JSON? Yes. It's a dictionary. So actually, we'll come back to this in a bit more in a moment. But JSON is a pretty common data type used for a lot of web services. It is a dictionary, or it can be a dictionary, lists of dictionaries. We'll come back to it in a moment. But it is a common data type, and it's actually not rectangular. So we're going to think about how to transform that into a form we can use. And which is the best? There has to be a best, right? Who would really like to see CSV files in their folders? Yeah, I like CSV files. Who would really like to see JSON files? Web developers. Very cool. There is no best. That was pretty obvious, I guess, from the setup. They all are going to have their strengths and weaknesses. I want to talk about a bit of those now. All right, so let's say classically, a data scientist, you know what, these are the file formats that we know how to open. They're already in tabular form. The records are delimited, often by new line, or if you're in Windows, the carriage return in a new line. So they have pretty reasonable rectangular structure. They can have different delimiters, sometimes commas, sometimes tabs, sometimes interesting like pipe characters, all of which we can open using our standard tools. Very common. What are some issues? Any issues with these? Here's a pretty standard one. What if someone puts a comma or a tab in their record? What if your name has a tab in it or a comma in it? What happens to the file? How do I split it anymore? I can't just split on tabs, right? So to deal with these kind of annoyances, that the data might actually have, the things that we're using as a delimiter inside of the data itself. There's a fix. The fix is quoting. So we put quotes in. Of course, now we have to make sure there are no quotes in our files as well. We can put escape characters in the quotes. It can be an entire mess. So fixing these can be a problem. In the homework that just went out, I had to go through this process with the IMDb data set. And it's a mess. They have weirdly quoted strings. These strings can also have different character encodings themselves, so I have to deal with non-Unicode representations. So just being a TSV or CSV sounds simple and clean, but there are many ways in which these things can go wrong. And unfortunately, a lot of your time will probably be spent fixing them. All right, so that's common tab separated. Pretty standard. They have their limitations. You need to watch out for them when you're loading them. JSON. So this is JavaScript object notation. It's very related to the dictionary you already know in Python. In fact, in syntax, it looks very similar to what you would use for a dictionary, except I think false and true can be lowercase here. Okay, so JSON, widely used. One of the things it's widely used for is it can represent nested data. Dictionaries can contain dictionaries, which contain lists of dictionaries, and so on. So we can build pretty rich data structures in this file format. There are strict formatting guidelines. So you actually can verify that a file is proper JSON. And the parsers will automatically deal with some of these annoyances we described earlier around how we represent interesting characters and strings. So there's already structure in place to deal with those issues. All right, so this sounds better. What's wrong with this format? It's not rectangular. Yeah, so it's got a lot of nice things about it, but one of the things that is probably most challenging, and something we actually have tools to address as well, is that we can have tables which contain records, which contain tables, which can contain records, which again can contain tables. So how do you make sense of this? You'll have to find ways to extract the important information from that JSON, and in typical cases, transform that into one simple table to process. Another one is that we can have records with different fields. So remember, in the CSV, we had like com labels, and then each record was sort of a list of things. And assuming each of those lists is the same length, we might imagine that each of those things corresponds to their appropriate column. In JSON, you go, you know what, this record has some extra information. We'll deal with tweets at some point. They're encoded in JSON, and some tweets will have different fields than others. And you'll have to deal with that. It's not so bad, but you have to deal with the fact that you'll have different representations for each of the records. As you already mentioned, nesting. XML. Who's used XML before? Yeah, okay, so XML is the data format for the web, or at least it was. JSON seems to be kind of taking over that role. But XML is sort of, you take the idea of HTML and apply it to data. It uses a similar kind of tag structure. It lets you represent these recursive data structures pretty naturally. There are ways to verify it. In previous versions of this class, we actually spent some time on how to query and process XML. That we might try to get that to at the end of this semester. But in practice, you can probably look up tools to process your particular needs for an XML file. So if we don't get to it, it won't be the end of the world. Just know that there's another format that looks like this, and it will have these standard tags you would see in an HTML document to encode data. Actually, it is worth noting that Pandas has a read underscore version of most of these. So read underscore JSON will read your JSON files. Read underscore XML will read your XML files. There's a catch that if they have interesting structure, you might have to pre-process them a bit before you can pass it to these tools. All right. So that's all the kinds of data you might see. No. All right. So what are other kinds of data you might see in the real world? Excel files. Yes, you might see Excel files. That is a good point. I don't have that in my lecture. Great news. Pandas can read Excel files automatically. In practice, a lot of people will export their XML file in the friendly CSV or TSV format, and then you will get to process it in that form. Yep. SQL files. What's an SQL file? Good. So SQL queries are nice because the data is actually going to have typically a representation that you can directly pull into your data frame. And its schema will be enforced by the database. So SQL Alchemy, which you might use in this assignment, provides a nice mapping from the relational model into your Python environment. And then Pandas has tools to just directly take a SQL query, a database to point to, and then slurp that data into Pandas. And it does a pretty good job of pulling out the appropriate schema information. So that's convenient. When someone goes, my data's in the database, like, all right, well, some of the data cleaning problems are going to be gone, but definitely not all of them. There's still plenty to mess with. What else? Images, video, we're not going to talk about that in this class. There are tools for processing those. I would say actually they're still in their infancy for data science tooling. So if you're like, I want to build new tools to help people do data science, building tools to bring in images and videos into a table, that would be neat. There's this last kind. This is really common, really annoying. Log files. So these were put together by someone who probably wasn't thinking a whole lot about trying to reread them into some other software artifact. What's the structure of these files? How would you begin to process that? I think they do represent records. Each of these boxes is a record. And they have different fields. They're organized with spaces and interesting delimiters throughout. So each of these records is just a string, basically. And you're going to have to use string tools to pull out the appropriate information from that string into a table. And it gets even better when people update their logging software, and so somewhere through the file, the format changed, and you have to deal with that as well. Yep. So that's what the real world looks like. A lot of the tooling that people sell for data science is addressed towards these kinds of problems, where it's just really a mess. All right, so that's a key part of the structure. How's data organized? What's the file? You should be able to look at a file, okay, I have a rough idea of what file format this is, and start to think about what tools you might use to process it, and what problems you might have to deal with in the process of doing that.